Hello and welcome to Diodes Part 1. Before we get started, I'll just give you a couple of rules of thumb that can speed up the solution of the Level 1 and Level 2 problems quite significantly. First of all, as a general rule of thumb, the voltage across a silicon diode, which is forward biased, in other words the anode here is at a greater potential than the cathode, is about 0.6 volts if the current is less than about a milliamp, and maybe 0.7 volts if the current is greater than 10 milliamps, and somewhere in between if it's somewhere in between those two currents. Not exact, does depend on the diode quite a bit, but as a general rule of thumb, that's probably good enough for Level 1 and Level 2. The current through a silicon diode which is reverse biased, in other words the voltage at B is greater than the voltage at point A, is given by, provided that B is more than about a volt above A, is given by the saturation current of the diode, which should be specified in the question. A Zener diode, provided that A here is greater than B, behaves exactly the same as a silicon diode. A Zener diode which is reversed biased, in other words that B minus A is greater than 0, well, if B minus A is greater or equal to the threshold breakdown voltage of the Zener, and that will be specified in the question, then you can assume that there'd be quite a lot of current flowing through it. At level 1, you can probably assume that the voltage across a Zener diode in breakdown is equal to the rating of the Zener diode. At levels 2 and 3, and certainly at level 4, that assumption is no longer accurate enough, and you'll have to do a bit more of a calculation about it. However, that should be enough for level 1. If B minus A is greater than the threshold voltage, then B minus A is approximately equal to the threshold voltage. In other words, B minus A cannot be bigger than the threshold voltage. Right. Let's try some questions. Here we have a Zener diode, but it's forward biased. So it's going to behave exactly the same way as a normal silicon diode. So we have a 4.5 volt voltage here flowing through a 680k resistor. If we take the 4.5 volts and we divide by 680k, then that's going to give us sort of the maximum current. Even if the voltage across that diode there was 0, the maximum current that would be flowing in the circuit would be about 6 microamps. That's a lot less than a milliamp, so I'm going to assume that the voltage across this Zener diode, using those rules of thumb we had, will be about 0.6 volts. So the voltage across here is 0.6, the voltage at this point here must be 3.9. So the current I'd expect to read about 3.9 volts divided by 680k. And close enough. Great. Here we have a reverse biased silicon diode, so there's only going to be about 2 nanoamps flowing through that silicon diode from here down to ground. And since we've got 8.1 volts here and a 240k resistor, the voltage across that 240k resistor is only going to be 240k times 2 nano, about 0.00048, that's 0.48 millivolts. So the exact answer I would expect to be 8.1 minus 0.48 millivolts, or 8.09952, but 8.1 is good enough. Just assume that no current is flowing down through this diode at all, and therefore the voltage that you measure will just be equal to the voltage source here. Right, we've just done that one. This time you'll notice the diode has swapped direction. So now this diode is forward biased and will be taking quite a lot of current. How much current? Well, not that much. even if that diode had no voltage drop across it at all, the current flowing in this circuit would be limited by this resistor to 1.4 divided by 100k, about 14 microamps. So there's not much current flowing through that resistor, so I could assume the voltage across it would be about 0.6 volts, and I might say 1.4 minus 0.6, that'd be close enough. Sorry. What am I talking about? That's the voltage across this resistor here. The voltage measured by the voltmeter would be the voltage dropped across the diode, and that would be the 600. Great. Close enough. Exact answer quite a bit less, but our rules of thumb got me close enough for level 1. See if we can find another one with a Zener diode in breakdown. Ah, there we are. Here's a Zener diode which is reverse biased. Its cathode here is at a higher voltage than its anode here. And since it's an 8.2 volt Zener, we can assume that this voltage here will be about 8.2 volts. So I could just write down 8.2. If this voltage here was less than 8.2 volts, then I could assume that that Zener diode was not taking any current at all, and therefore the voltage reading here would be just equal to the voltage reading at the voltage source. But because the Zener diode has a breakdown voltage which is less than the voltage source, then we can assume that the Zener diode is in fact in breakdown, at which point it will clamp this point here to be approximately 8.2 volts. Right, hopefully you're beginning to get the idea. It does get a little bit more tricky when we move up to level 3 and level 4, and these rules of thumb are no longer accurate enough.